Thank you. I'm going to talk about distance to truth, or some notion thereof. And I'm going to talk about accuracy first, those who wish to use such a notion to argue for the Bayesian norms of rationality. And as you can tell from the title, I'm going to have some critical remarks on that. So I figured that actually a lot depends on, concerning the points I want to make, a lot depends on, let's call them big picture considerations. So I will actually, the largest part of the talk will be the setup for the technical points I wish to make. Yeah, in this setup, I will talk a lot about, just general perspectives on accuracy first epistemology. So the first three sections will be the setup, then the rest will be technical details. And actually, I'm just happy with the setup is what's most important and what's philosophically most interesting, I think. Okay. Yeah, so Bayesianism is a theory of credences. So it gives rationality constraints for degrees of beliefs. And it's a formal theory and formal epistemology, and the formal apparatus that it uses to formulate the rationality constraints is probability theory. Now, in the area of theories of credences, Bayesianism is definitely by far the most dominant theory, and it has been for many decades. One evidence for this is the crazily wide variety of fruitful applications, both within but also outside of philosophy. I'm not going to name them. I think you will have heard of Bayesianism in some context or another. Although Bayesianism is super dominant, there are rival theories, right? There are alternatives. So, for example, ranking theory is a very well elaborated alternative theory that gives simply incompatible norms, right? So that it just does it differently, right? And for this, and obviously other reasons as well, it's worthwhile for Bayesians to try to give arguments for their norms of rationality. And accuracy first epistemology is supposed to contribute to giving such arguments. It's a Bayesian research program. The goal is, broadly speaking, to supplement the Bayesian norms with an appropriate epistemic axiology. By that I mean an appropriate account of epistemic value. And as the name accuracy first already tells you, they believe that accuracy is the core epistemic value of credences. In fact, they believe it's the only kind of epistemic value that credences can possess. And this idea is called a creedal veritism. So how does this work? First, accuracy first is formally characterize accuracy, or rather how to measure it. And they do so on the basis of the idea that accuracy is something like closeness to truth. And second, on the basis of this formal characterization, they simply give a theorem or theorems that prove that adherence to the Bayesian norms in some sense promotes accuracy. So the Bayesian norms are in some sense accuracy conducive or truth conducive. The goal of this talk is, or my thesis is, I want to argue that it is unlikely that the current way of justifying such appropriate measures of accuracy, and by appropriate I mean measures that verify the theorems they want to prove, can at all be successful. So because of the modal claim can, this is quite a strong thesis, but also there are some qualifications in there, unlikely, current way, and so on. And I hope the setup will clear up what I mean by that, what exactly I mean by that. But this is the goal. Okay, so here comes the first part of the big picture considerations. I think there are at least two views one can have on accuracy first epistemology. And I'm going to tell you about those two views, and I'm going to tell you which of the two views I will presuppose in this talk and why I want to presuppose it. So first, there is what I call the deductive argument view. And according to this view, accuracy first epistemology is simply supposed to give valid and sound arguments for the Bayesian norms. So accuracy firsters provide first a list of supposedly true premises, creedal veritism, the claim that epistemic value is given by accuracy, a formal characterization of accuracy, and a suitable norm of rational choice that implies, together with this axiology, the respective Bayesian norm, right, which is proved in a second step in the form of a theorem. Now, importantly, in order for these arguments to be convincing, the premises have to be justified, right? And they have to be justified in a non-question begging way. They have to be justified on neutral grounds, if you like, right? On grounds that are, in principle, acceptable to a dialectic opponent, for example, to a ranking theorist. The second view one can have, I call the coherent package view. And according to this view, accuracy first epistemology is quote unquote only supposed to show that there's a coherent package of Bayesian norms and epistemic axiology. Right, so a non-question begging motivation for this axiology is not needed. Maybe we want consistency with some basic commonsensical principles or something like that, but the goal is not to argue on neutral grounds for this axiology. That's an upside. The downside is obviously that the mere existence of such a coherent package is not itself a convincing argument for the Bayesian norms, right? Because there could be other coherent packages. And in fact, ranking theorists have proposed their own axiology that supports their own norms. So there are other coherent packages. If you want to give an argument for Bayesianism according to this coherent package view, this requires a careful comparison of the existing packages. And to my knowledge, this has simply not yet been done. So according to the coherent package view, accuracy first epistemology has not yet delivered a complete argument for Bayesianism. So now what? Here's what I think. I think the coherent package view is more plausible, given what accuracy first epistemology has done so far. And actually, it seems to me that many accuracy firsters themselves endorse it, right? I have absolutely no solid proof for that, but personal communication. But what is explicitly presented in the literature, at least in large parts of the very prominent literature, is the deductive argument view. So here I've listed, I think, the three main and most influential contributions to accuracy first epistemology so far. Jim Joyce's original paper from '98 that started it all, Lightgib and Pettigrew's double paper from 2010, and Richard Pettigrew's book from 2016. And in all of these contributions, what's happening is they actually list premises from which the Bayesian norms deductively follow, and they try to argue for these premises. And actually, Pettigrew, in particular, in his book, he actually tries to explicitly avoid question-begging justification for the justifications for the premises. Right? So this is just, I think, these three most prominent contributions definitely and explicitly presuppose the deductive argument. So I think it's fair and worthwhile to examine the success of accuracy first epistemology under this assumption, and this talk is supposed to contribute to this. All right. So let's get back to characterizing inaccuracy, and because we are in the deductive argument, you justifying characterizations of accuracy. Now you notice in the title of this section, I'm talking of inaccuracy. Accuracy first is like to switch back and forth between accuracy and inaccuracy, closeness to truth and distance to truth, epistemic value and epistemic disvalue. Right, and there's no harm to it. This is simply a terminological issue. So if you characterize inaccuracy, you also characterize accuracy, obviously. So here's the most basic idea about distance to truth. It's called truth directedness. I've written it down here in a general form, but that's not so important. The basic idea is much more simple, much simpler. But suppose you have a credence function and consider one particular credence in that credence function. And suppose it's a credence in a true proposition. Now, if you raise that credence, then you will overall, while the rest of your credences stay the same, you will then overall be closer to truth. Likewise, if you lower your credence in a false proposition, rest staying the same, you also get closer to truth. So basic idea in terms of accuracy, high credences in true propositions and low credences in false propositions are good in terms of accuracy. Okay, and this principle I've written down on the slide is simply a general version of this. Now this has an important consequence, namely that the most accurate or true, or Pettigrew calls it the omniscient credence function, is the one that assigns the maximal credence of 1 to all true and the minimal credence of 0 to all false propositions. This is the most accurate or true or omniscient credence function. And the idea how to model distance to truth is simply to say that distance to truth is distance to this true credence function. Right, so we are measuring distances between credence functions when we're measuring distance to truth. Namely, we're measuring distance to the true credence function. Okay. Now here's 3 potential measures of distance to truth that all comply with this idea of truth directedness. First, we have the absolute value score, taking the absolute difference between, for each proposition, takes the absolute difference between your credence and the true credence and sums up these differences. Very natural, very straightforward. The Breyer score does exactly the same thing, only that it squares the differences before summing them up. And the Euclidean distance score again does the same like the Breyer score, only that it takes the square root after summing up. Okay, 3 very straightforward measures. Interestingly, out of these 3, only the Breyer score will verify the desired theorems, will verify that adherence to the Bayesian norms promotes accuracy. The Breyer score is not the only measure that does this. It belongs to the so-called proper scoring rules or Breckman divergences, and these are classes of inaccuracy measures that are good for the job, for the interest of the accuracy first. So what they want to do is they want to give axioms for inaccuracy measures, necessary conditions for inaccuracy measures that rule out those ill-suited measures like the absolute value score or the Euclidean distance score. And importantly, given the deductive argument view, they have to justify these axioms, right? Because they are simply premises in their argument, right? And they have to justify these on neutral grounds. There's one thing I want to get out of the way, namely that accuracy firsters who are trying to characterize inaccuracy measures are not like physicists trying to devise a good measuring device for electrical charge or whatnot, right? So that's not what's going on. Instead, what they do is they engage in conceptual work. This is a presupposition, an important one. I will I won't argue for it in any way, because I think it's rather obvious, and I haven't met anyone who has denied this. But if you have worries about this presupposition, then please let me know in the Q&A. Now, what can it mean to engage in conceptual work? I think it can mean any of the following three things. It can mean that accuracy firsters engage in conceptual analysis. This would mean that inaccuracy measures capture features of some kind of pre-existing, perhaps vague and imprecise concept of inaccuracy. The second option is stipulation, right? There is no pre-existing concept of inaccuracy, and instead accuracy firsters just define a completely new concept. And third, there's perhaps a mixture out of analysis and stipulation. I call it here explication. And the idea is that there is a pre-existing, perhaps vague concept of inaccuracy. And characterizing inaccuracy measures is supposed to make this pre-existing concept more precise, or to explicate it in the Carnapian sense, or to somehow change it for the better, right? I call it explication here, but this is maybe a bit too narrow. Maybe conceptual engineering or something like that would be a more appropriate term. Now, interestingly, this again makes for three views one can have on what accuracy firsters do. And in this case, I know of no explicit adherence to one of the three views. But I'm going to tell you what I think what's going on, or at least what I think accuracy firsters in some sense claim to do. I want to rule out stipulation right off the bat because I think there isn't a pre-existing concept of inaccuracy. The simple fact that we can think about the principle of truth directedness and find it intuitively plausible seems to me to suggest that there is something, that there is some kind of pre-existing idea of inaccuracy. So this leaves us with analysis and explication. And now we're going to think about what's going on, which of the two it is. So first of all, note an important difference between the two. Conceptual analysis produces descriptive statements about a concept, right? It's about how a concept is and how it functions or what it is. Explication, on the other hand, produces normative statements. It says that we should change a certain concept in a certain way. And this difference is important for the kind of arguments that you have to give for analyses versus explications. So analyses can, for example, can be justified by linguistic intuition. That's what maybe philosophers tend to do. But you can also, of course, give empirical studies like linguists do. Explication, on the other hand, require at least in part some kind of normative argument because it produces a normative statement. So one perhaps popular source of such a normative argument would be fruitful applicability of the concept in sciences, right? I guess this is an important example from Kana. But more generally, appeal to theoretical or explanatory unification in the respective field is a good thing. But the central point is simply explication requires normative argument in contrast to analysis. And here's the thing. I know of no normative argument for a complete characterization of inaccuracy measures given by an accuracy firster. There are such arguments, no doubt. Actually, they've been around for a really long time, but not given by accuracy firsters. A debatable case might be Joyce's 2009 paper, but I don't think Joyce is or ever has been an accuracy firster. So I don't think that counts, but that's debatable maybe. But definitely the three main contributions that I've already cited, they do not give normative argument. Instead, when talking about the properties of inaccuracy that are encoded in those axioms, they speak of their intuitiveness, they speak of their naturalness, of their plausibility, absurdity of the alternatives, and so forth. And given the previous considerations, especially given my presupposition that accuracy firsters engage in conceptual work when characterizing inaccuracy, this sounds a lot like appeal to linguistic intuition. And actually, it's not explicitly said that this is supposed to be linguistic intuition, but I simply can't think of an alternative way of interpreting this talk, right? Given that they engage in conceptual work. If you have an idea about that, please let me know in the Q&A. Okay. So given this apparent appeal to a linguistic intuition, given that there's no normative argument, it seems like accuracy first is engage in analysis rather than explication. And that's super surprising because that's not normally what formal epistemologists do, right? Usually formal epistemologists replace vague and imprecise existing concepts by new, more precise concepts, right? They engage in explication. So it's really surprising that accuracy first seem to engage in analysis, or at least they give arguments that would fit an analysis. Okay. This is the second big picture consideration, and I will presuppose the analysis view. Now I want to slip in a quick remark, namely that the coherent package view and the explication view just fit perfectly together. If there's no ambition to justify the axiology on neutral grounds, we can presuppose acceptance of the Bayesian norms. And in this case, choosing inaccuracy measures that provide a normative foundation for these plausible and accepted Bayesian norms is exponentially unifying. To put differently, the fact that a certain explication of inaccuracy fits well into a coherent package with supposedly plausible and accepted norms of rationality delivers at least part of the required normative argument for this explication. Of course, this normative argument is not on neutral grounds, right? Because it requires acceptance of the Bayesian norm. So it's not acceptable to a ranking theorist, for example. But again, we are in the coherent package view, so this is not needed. And if I were an accuracy first, I've still not decided after all these years, but if I were, I would probably endorse the coherent package view together with the explication view. And likewise, the deductive argument view fits well with the analysis view, right? Because linguistic intuition or empirical studies used to argue for analyses, they seem to provide the kind of neutral ground that is required to non-question beggingly argue for a certain characterization, which is needed in the deductive argument view. Okay, but back to the deductive argument view, back to the analysis view. Regardless of these views, it's clear that accuracy first require a quite narrow characterization of accuracy, right? So for example, the absolute value score is super straightforward and intuitive, I think, but it has to be ruled out. The Euclidean distance score is very similar to the Breyer score. In fact, it's an order-preserving transformation of it. That is, it orders the credence functions according to their accuracy exactly like the Breyer score. Only difference is it assigns different numbers to them. And it would be extremely surprising if some pre-existing concept of inaccuracy is able to not only fix the ordering of the credence functions, but also the numbers. That's just weird, right? So in general, the worry that I have is that our pre-existing, vague, perhaps ordinary language concept of accuracy is simply not precise and determinate enough to be only compatible with, for example, the Breckman Divergences or the proper scoring rules or some similarly narrow set of measures. This is the worry. This is what I worry about. An extreme case is probably Pettigrew's 2016 attempt to justify the Breyer score as the one and only legitimate inaccuracy measure, right? And offhand, given the analysis view, it would be almost absurd to think that, whatever the pre-existing concept of distance to truth is, it's only compatible with this particular mathematical measure, right? Would be very, very surprising, at least. Okay. So this concludes the setup. I've taken 25 minutes, not too bad. Let's talk about how I want to substantiate and deepen this initial worry by having a look at the technical details of the characterizations that have been put forward. So first of all, note that this initial worry, makes a prediction, right? If the pre-existing concept of inaccuracy is not precise enough to warrant the narrow kind of characterization, then the narrow kind of characterization will not be sufficiently backed by linguistic intuition. So if we find out that this is true, when we're looking at the specific proposals, then this substantiates the initial worry. Even more so, if we find out that the trouble with these characterizations, the lack of intuition, is always with respect to a specific property of the Breckman divergences or the proper scoring rules. Right? So if there's a specific property that is required by the theorems or by appropriate characterizations, but that is not intuitive, then this makes it seem all the more unlikely that there will be a future successful justification by linguistic intuition of an appropriate characterization. Even more so, of course, if this troublemaker is not only unintuitive, but actually counterintuitive. Okay. And as you can imagine, in what follows, I want to argue that in the cases I'm about to consider, all three steps apply, which in the end will make it, according to, in my opinion, will make it seem unlikely that that the current way, right, of justifying the characterizations by linguistic intuitions can at all be successful, which was the thesis that I wanted to argue for. So I'm going to look at two case studies. I'm going to look at Jim Joyce's 98 proposal. I'm going to pick out the axiom of weak convexity. I'm also going to look at Pettigrew's latest proposal from 2016. I'm going to look at his axiom called decomposition. I'm going to leave out Lightgate and Pettigrew's double paper from 2010, simply for time limitations, but I could make similar points, though less instructive points concerning their paper. So for the purpose of the talk, you will just have to trust me that nothing unexpected turns up in this proposal. Okay. All right, let's start with weak convexity. The axiom says something about what Joyce calls the equal mixture of two credence functions. And the equal mixture of two credence functions simply assigns to every proposition the arithmetic mean of the credences that the two credence functions assign to that proposition. And weak convexity says the following. If we consider two equally accurate credence functions, then their equal mixture will always be strictly more accurate. This is what weak convexity says, and it's simply the definition of convexity, actually of the definition of strict convexity. So calling it weak convexity is kind of a misnomer, but it's straightforwardly just the definition of strict convexity. How does Joyce want to argue for this? He thinks that weak convexity is supposed to capture our intuitions. Note that he's appealing to intuition about how accuracy changes when we change our credences. In particular, he thinks that if we consider these three credence functions and we move from one to the equal mixture to the other, then we make two steps in the same direction and of the same magnitude, says Joyce. And he thinks that in such cases, we get counterintuitive results if we don't require weak convexity. He says if it did not hold, one could have absurdities like this. I raised my confidence levels in X and Y, and my beliefs became less accurate overall. So I raised my confidence levels in X and Y again by exactly the same amounts, and the initial accuracy was restored. And it's true that weak convexity rules this out. By requiring that the equal mixture is strictly more accurate, it cannot happen that it's strictly less accurate. But obviously, reconvexity also rules out that accuracy stays the same. And this doesn't seem counterintuitive, or at least Joyce hasn't given an argument that it's bad. So as Meyer and Pettigrew have pointed out, the argument is simply not valid. The intuition that Joyce cites is not sufficient to justify the axiom, right? So our prediction, the prediction of the initial worry came true. Reconvexity is not sufficiently backed by intuition. What's more, however, I think that it's actually counterintuitive, and it's counterintuitive in the light of Joyce's intuition, or at least of what appears to be Joyce's intuition, which is something like this. Namely that a certain change in credence should always change accuracy in the same direction, right? So it would be absurd if the two-step move, if making the same step twice, would first result in a decrease and then an increase in terms of accuracy. This Joyce finds absurd, and I agree. At least there's something wrong. I feel uneasy when thinking about it. But I feel equally uneasy, it feels equally absurd to first have an increase and then a decrease in accuracy. Right? So intuitively, there's no asymmetry between the two sequences. And the intuition that Joyce cites seems to speak against both sequences. But obviously, the second sequence, the increase-decrease sequence, is precisely what reconvexity requires, because it requires the equal mixture of two credence functions to be strictly less accurate. The equal mixture of two equally accurate credence functions to be strictly more accurate. Sorry, that it's strictly more accurate. And this is counterintuitive by the very intuition of that Joyce cites. Okay. This concludes my case study of Joyce's reconvexity. I return to it later. Let's now have a look at Pettigrew's axiom called decomposition. In order to state and understand it, we need to talk about calibration first. The idea is simple. Your credences are well calibrated if and only if 80% of the propositions believed to degree 0.8 are true, 70% of the propositions believed to degree 0.7 are true, and so forth, right? And if that's not the case, if you're not well calibrated, for example, because only 60% of the propositions believed to degree 0.7 are true, then you can calibrate your credences by assigning the correct value of 0.6 to those propositions, 60% of which are true. And if you do that with all the propositions, then you get the well-calibrated counterpart of your credence function. The formal definition of this is on the slide, but it's basically what I just said. So what does decomposition say? Decomposition says the following. If we measure distance to truth, this is the distance here on the left side of the equation. That is distance between my credence function and VW, that's the true credence function, the indicator function. If we measure this distance, it decomposes linearly into two different distances. First, distance between my credence function and its well-calibrated counterpart. Second, distance between my well-calibrated counterpart and the true credence function. And if we sum these two distances, perhaps in a weighted way, then we get the overall distance between my credence function and the true credence function. That's what decomposition says. And because the opposite of this distance, of the first distance, is calibration, or can be called calibration, and the opposite of this second distance can be called, or is often called, resolution. The basic slogan is accuracy equals calibration plus resolution. So there's two parts to accuracy: calibration on the one hand, resolution on the other. Now, how does Pettigrew want to argue for this? The basic idea is that decomposition implies a certain intuitive principle, namely the following ceteris paribus principle. If you hold constant the second distance, if you hold constant the resolution, then the first distance to the well-calibrated counterpart and the distance to the truth they increase and decrease together, right? So they correlate in a very strict sense. And this principle I call CP correlation, because in ceteris paribus situations, calibration and accuracy correlate. And CP correlation is obviously just implied by decomposition. And Pettigrew wants to argue for decomposition by saying that CP correlation is intuitive. And he actually gives examples that are supposed to show that it's intuitive. And decomposition is justified because it captures these intuitions. All right. I don't think this works. So for one thing, just because consequence is intuitive doesn't mean that the overall principle is sufficiently backed by intuition. There are other alternative principles that equally deliver CP correlation. So this intuition is not sufficient. But also, I don't think that this intuition exists. I don't think that CP correlation is intuitive. I don't think it's intuitive as a general principle, just like that. And I also don't think it's intuitive in the examples that Pettigrew gives, right? Yeah, I should say that I get the intuition that calibration is somehow valuable, that it somehow hits the mark or gets something right? It just sounds nice to say that 80% of the propositions believed to degree 0.8 are true and so forth, right? It sounds like there's something good there, it's something valuable. But that's not what Pettigrew requires. He requires that there's this tight correlation in certain circumstances, this tight correlation between distance to being well calibrated and distance to maximally believing all true propositions and minimally believing all false propositions. And offhand, I'd see, well, these are just two different things. I don't see why they should be intuitively correlated. But let's have a look at the example. Pettigrew considers a 10-ticket lottery, 10 propositions, each saying that a certain ticket wins. He only considers uniform credences over these 10 propositions. As a direct consequence, resolution is constant and CP correlation applies. Now, if CP correlation were intuitive, we would find it intuitive that in such cases, the well-calibrated credence function is closest to the true credence function. And this I simply don't find intuitive. Maybe to make this a bit more clear, look at this example. On the bottom row of the table, we have C star, which is the well-calibrated credence function assigning 1/10, because 1/10 of these propositions is true. On the top row, we have an alternative credence function assigning 100 to each of the 10 propositions. And in the middle, we have a true credence function. Here, I suppose that the 10th ticket wins. So first note that 9 of these propositions are false. So for 9 out of 10 cases, C assigns a smaller credence to a false proposition, and thus is better in terms of the accuracy of with respect to this particular credence. And then only in the 10th case, C star assigns a larger number to a true proposition and gets it right in this 10th case. So in order for C star to be overall intuitively closer to the true credence function, it would have to be intuitive that the better accuracy in the 10th case way up. And this we don't find intuitive. In fact, you might actually have the intuition that the 9 cases outweigh the 10th. And if that's true, if that is intuitive, then CP correlation is counterintuitive, and therefore decomposition is counterintuitive. Okay. This concludes my case study, my second case study. Let's talk about how this substantiates the initial worry. So first of all, the expectation that comes out of the initial worry came true, right? The previous characterizations, or at least the two we have looked at, are not sufficiently backed by intuition. And this alone, I think, already substantiates the initial worry. Second, I think that in both cases, the lack of intuition is in terms of a particular property of the required characterizations, namely the convexity of distance to truth. For Jim's weak convexity, this is obvious because it simply explicitly uses the standard definition of convexity. But I also think that you can argue this similarly in the case of Pettigrew, because Pettigrew considers additive measures. For example, the absolute value score, the Bryce score are additive measures. And in those cases, when you're dealing with additive measures, convexity means that with respect to the local accuracy that is added up to get global accuracy, that with respect to the local accuracy, moving away from the truth is punished harder than moving towards it is rewarded. If that's the case for the local accuracy that you add up, then the global accuracy is convex. So remember the 10-ticket lottery case. Imagine we start out with C star and uniformly lower the credences to 100th, right? Then in the 10th case, in 9 out of 10 cases, I move towards the truth. And in the 10th case, I move away from the truth, right? Because I assign a smaller credence to a true proposition. In order for us to find it intuitive that overall we're moving away from the truth, which is what Pettigrew would require, because only then C star would be closer to truth. In order for us to have that intuition, we need to have the intuition that moving away from the truth is punished way harder than moving towards it is rewarded, which is precisely what convexity says in the case of additive measures, which Pettigrew is considering. So again, it seems to be that the problem seems to be that we lack an intuition in favor of the convexity of distance to truth. So the second step applies as well. Now the third step, is convexity of truth counterintuitive? I think we might have intuitions against distance to truth. Right? I think it's particularly salient in the case of Joyce's weak convexity, that we found that this intuition that a certain change should not in one case lead to an increase and another in a decrease of accuracy, that this intuition speaks against weak convexity. And if we have that intuition, then convexity is counterintuitive. And maybe we also have the intuition that moving away from the truth should not be punished way harder than moving towards it is rewarded. And if we find that intuitive, that this should not be the case, then we have intuitions against convexity. At this point, I want to consider a possible objection to the intuitions against convexity. So it could be argued, as for example, Jim does in his 2009 paper, that non-convex measures of epistemic disvalue deliver absurd results because they do not punish or even encourage to change one's credences over the flip of a coin. Right? This alone is no objection yet, but it could be made into an objection as follows. Since the accuracy firster believes in credo veritism, that is, she believes that inaccuracy is all there is to epistemic disvalue, using non-convex inaccuracy measures means using non-convex measures of epistemic disvalue, and this in turn delivers absurd results. Thus, we shouldn't trust our intuitions against the convexity of inaccuracy, says the objection. My short response to this objection is simply, well, all the worse for claiming that inaccuracy is all there is to epistemic disvalue, right? All the worse for creedal veritism. If our pre-existing ordinary language concept of inaccuracy simply is non-convex, as our linguistic intuition perhaps tells us, if that is the case, then this is a problem for the accuracy first. It's a problem for the creedal veritist. How can this be turned into a problem for her dialectical opponent? Okay. So to sum up, I believe to have shown that at least two previous characterizations have not been sufficiently backed by intuition. In particular, convexity seems to be not backed by intuition. And in fact, convexity seems to be counterintuitive, perhaps. Right. So to the extent that convexity of inaccuracy is indispensable for showing that adherence to the Bayesian norms promotes accuracy, it seems unlikely that intuition alone can justify an appropriate characterization of accuracy. And obviously, you don't have to accept all 3 points in order to have this worry, or to think that it's unlikely. So, for example, if you're not so sure about your intuitions against convexity, but you accept the first 2 steps, then this already substantiates the worry and makes it seem unlikely that this can be successful. Okay. What are possible reactions by accuracy firsters? I think accuracy firsters can answer in at least 3 ways, right? The most simple and conservative answer is, well, not all hope is lost. Richard, chill out. It's not everything's decided yet. Maybe there is still a possibility for intuitive justification for convexity, or maybe we don't even need convexity for the theorems, right? Perhaps it's not necessary to appeal to convexity. I don't think this is very likely to be successful. The second option is to say, well, let's drop the claim that convexity is intuitive and argue for convexity normatively, right? Let's do explication instead of analysis, right? And actually, in the deductive argument view, this would have to be done on neutral grounds, right? So these normative arguments have to refer to normatively positive qualities of the explication that are acceptable or that appear positive also to dialectical opponents, not just Bayesians. If we are still in the deductive argument view, that is. I'm not very hopeful that this can work. What I think accuracy firsters should opt for is to abandon the deductive argument view and fully embrace the coherent package view in combination with explicating distance to truth, right? In the kind of way that I've explained before, right? So because the Bayesian norms are plausible and convex measures of inaccuracy deliver the Bayesian norms, convexity there's a normative argument for convexity or for accepting a convex characterization of inaccuracy. And in fact, this only requires rephrasing the accuracy firsters claims, right? We have to step down a notch, say, well, we don't have valid and sound arguments, but we can show that this is a coherent package. The price is we would have to compare the Bayesian package with, for example, the ranking theoretic package. So let me conclude. I suggested convexity of distance to truth is not intuitive. In fact, it might be counterintuitive, but accuracy firsters can sensibly argue for convexity by adopting the coherent package view, in which they can presuppose acceptance of the Bayesian norms. And because convex measures of inaccuracy deliver the Bayesian norms or deliver a normative foundation for the accepted Bayesian norms, we can argue that a convex characterization of inaccuracy is a good explication, not analysis, explication of the concept of distance to truth. This requires rephrasing the results a bit more modestly, and it requires comparing the Bayesian package with alternative packages. But I think given the considerations I've put forward in this talk, this is more or less inevitable. But I'd like to hear your opinion about this, and I'm looking forward to Bernhard's response. Thanks a lot.